In this video, we're going to talk about everything you need to know about matrices to be successful in the ACT. If you would, please give this video a like and subscribe for more math help. All right, first thing we need to know about matrices is how to describe them. We describe them by the number of rows and the number of columns. So, if a matrix looks like this, we say that this has 2 rows. Rows are over here. It has 3 columns, so we call it a 2 by 3 matrix. Okay, so that's the first thing. Now, to add or subtract, I should say, matrices together, they need to be the same size. So you can see a 2 by 2. Like that. To add matrices together, you simply locate the spot in the same cell. So upper left, you just do that operation. So 1 plus 1 creates a matrix. We get 2. Next, 3 and 4. So lower left is 7. Negative 2 plus 6 is 4. And finally, 4 plus 0 is 4. So that is the way we add matrices. They have to be the same size. The resultant matrix will also be the same size, and we just find the common spots, upper left, in the same locations. Now, subtracting matrices, very, very similar to that. Let's make it a little bit different size this time. Like that. So, again, how we would describe these matrices, just because it's good to know, both of these matrices have 2 rows and 3 columns, so they're both 2 by 3. And we once again just say, well, we're going to go in the same location, each matrix, and just perform that operation with those numbers. So the very first one, we're going to have 4 minus 6. We're going to have negative 2. I'm going to go down then to here. So we're going to have 2 minus 1. Then I'm going to go up, so negative 3 minus negative 2. Be careful, minus a negative is plus, so negative 3 plus 2 is negative 1. Then 1 minus 0 is 1. 4 minus 3 is 1. 0 minus negative 4 is positive 4. So adding and subtracting matrices results in a matrix that is the same size, and we just perform the operations on the similar spots. The other matrix operation that you might need to know is called scaling. Scaling a matrix takes a matrix and multiplies it by kind of an outside number, something like that. We put the number out front. And basically we're just saying we're doubling this. We're doubling this matrix. We're adding 2 of the same together, which means we just do that operation on each individual piece, like that. Okay. Now the last operation that you might need to perform on a matrix on the ACT is multiplying. And that's multiplying 2 matrices together. Now, I'm going to do this. I'm going to start small. Times. Now, first thing we do with a matrix, with matrix multiplication, is to describe the sizes. So we have a 2 by 2 here. Remember, it's rows by columns. Here we've got a 2 by 1. I would just write that every time right below it. These numbers, these inside numbers, the columns on our first matrix and the rows on our second matrix must be the same. Otherwise, we are not able to multiply our matrices together. The leftover numbers, here and here, this describes the new matrix that we'll get when we find the answer. It will have 2 rows and 1 column. Okay? Now, the way we multiply is sometimes what's referred to as the dot product. It's kind of a weird operation. we take this number, 1, and we multiply it by here, -3. And then we slide over, and we do 3 multiplied by 1, and we add those numbers together. Now I'm going to write all of that down. So we've got 1 times -3 plus 3 times 1. Then we go down here to our next row, and we do 4 multiplied by -3 and 6 multiplied by 1. So we always start with this first number to the top, and that's, so let me write that down, 4 times 6, nope, excuse me, times -3 plus 6 times 1. So let's calculate those. 1 times -3 is -3. -3 plus 3 is 0. That's my top number. 4 times -3 is -12. Plus 6 is -6. That's my answer matrix. Let's do one more that's a little bit bigger. That one. Again, let's start by describing it. We've got 2 by 3, and we've got a 3 by 2. So you can see, those are the same. And our answer matrix will be a 2 by 2. So, start here. We're going to do 3 times 1, 4 times 2, 6 times 4. We're going to add all of those together. So let's do that in our heads. 3 times 1 is 3. 8, so 3 plus 8 is 11. Plus 24 is 35. Okay. Now, we're going to do that row again. But we're going to slide over to the second column. So 3 times 3 is 9. 4 times -1 is -4. So 9 plus -4 is 5. Plus 12 is 17. Now, we've multiplied the top row by both columns. So now we're going to go to the bottom row and repeat. We're going to do 2 times 1. 1 times 2. So 2 plus 2. And then, of course, 0 times 4 is 0. So we've got 4. And finally, we do our bottom row times the second column. 2 times 3 is 6. 1 times -1 is -1. So remember, it's 6 plus -1 plus 0. So 5. This is our result matrix. Now, if you have a TI 83, 84, whatever, you can certainly do this with that. The matrix button is along the left side. On some calculators it has its own button, but on others it's a second option. So on mine it's second. You see that you have a list of matrices, get some math you can do, but you have edit. So what you can do here is you can change your size, 2 by 3, and you can enter the stuff in. I'm going to make a matrix up quick. Like that. Okay. Then I'm going to go back. I'm going to edit a second one. And remember, edit a second one. We want, so I'm going to make 2. We have to have our matrices, remember, have to have the same number of, the columns in the first have the same number of rows as the second. So I'm just going to make sure I do that. Make a matrix up here. And of course, you can't add these matrices because they're not the same size, but we can multiply them. And how we do that is we go in, matrix, you just choose matrix A times, back in, choose matrix B. You can see it'll give us the answer. And we can do this with all of the operations, and if it doesn't work, it'll give us an error message. So that's a really handy way to do this as well, because a calculator is allowed.